Today, we're going to dive into one of the most urgent, and I mean truly urgent conversations happening in technology right now. How do we build artificial intelligence that we can actually trust? To really get at the heart of this, we have to start not with some abstract theory, but with a real story. A story that is both shocking and was entirely preventable. It all begins with a single devastating piece of advice. Advice that was given by an AI healthcare agent in Kisumu to a patient with diabetes. The AI told her, "Skip insulin if you feel fine." And you know what? She did. She trusted the technology, she listened to the advice, she skipped her insulin. The result? She lapsed into a coma. I want you to just sit with that for a second. A life-altering, catastrophic event, all caused by a few lines of code. Now, you might be thinking, this must have been some malicious code, right? Some kind of bug or a hacker. But when the system was audited, investigators found that wasn't it at all. The real cause was something far more common and maybe even more dangerous. It was an ethical gap. A simple checklist, a set of foundational principles that should have been followed, was just skipped, all in the frantic rush to get the product out the door. This story isn't just a one-off tragedy, it is a massive warning sign for the entire industry. So how do we prevent this from happening again and again and again at an ever-increasing scale? Well, it turns out there's a framework for that, a protocol designed specifically to close these exact gaps. And that's what we're going to break down today, a 7-step, non-negotiable checklist for building ethical AI systems. So where does this framework come from? It's not from some academic ivory tower. It comes directly from the front lines, from the work of an engineer named Marcel Masaga, who has spent his career building AI in some of the most complex, high-stakes environments you can imagine. And all that hands-on experience has led him to focus on one core question, a question that every single person building AI should be asking themselves before they even think about writing code. And to really understand why this checklist is so grounded and so powerful, you need to understand who Marcel is. Yes, he's an AI engineer, but he's also a 5-time founder. He served as a fractional chief technology officer. For more than 20 years, he has been in the trenches building real-world AI systems, from diagnostic tools in East African clinics to globally recognized startups. This is an abstract theory for him. His work is deeply rooted in solving tangible human problems. He's also mentored other founders, he's advised investors on where to put their money, and he served on 5 different global AI ethics bodies. So he's seen this problem from every possible angle, from the startup garage desperately trying to ship a product, all the way to the global policy forums trying to write the rules. And all of that immense experience has been focused on answering this one central question you see right here. How do we build AI that doesn't just work, but actually matters? That is the core idea we are going to unpack today. So here it is. This is Marcel's answer to that big question. He calls it the non-negotiable launch protocol. And what I want you to notice is that ethics, in his view, isn't some fuzzy feel-good concept you tack on at the end. It's a system. And this 7-step checklist is the protocol he and his teams use before launching any new AI, especially when the stakes are high. This is our roadmap. Look at the steps. You can already see the logic. It's like building a house. You start with a solid foundation, the problem and the data. Then you build up the walls and the structure, the human safeguards. And finally, you put on the roof and install the safety systems, the systemic checks. This isn't just a list of suggestions. This is the blueprint for the difference between an AI that harms and an AI that helps. So let's start where you always should, with the foundation. Marcel calls these first 3 steps the foundational layers. Think of this as the concrete bedrock for the entire system. Because if this foundation is cracked, if it's unstable in any way, it doesn't matter how sophisticated or powerful the technology you build on top of it is, it's at risk of a catastrophic collapse. And it all begins with the most fundamental question. Step 1, define the problem clearly. Now, this sounds almost deceptively simple, doesn't it? But in the tech world's relentless race for innovation, it's often the first thing that gets ignored. Teams get so excited about the technology itself, a powerful new model, a faster algorithm, and they can forget to ask the most important questions first. Who specifically benefits from this? And just as important, who might be harmed by it? It's so easy to start with a vague, ambitious idea like, let's use AI to improve healthcare. But Marcel points out that this very vagueness is where the danger creeps in. A vague problem definition almost guarantees you'll get a vague, unfocused, and potentially harmful solution. To make this concrete, let's look at this case of a maternal health agent that was built in Nairobi. The team didn't start with a fuzzy goal. They began with an intensely specific mission: reduce late-stage preeclampsia diagnoses in Kisumu County. And this is their problem definition canvas for that project. It's a perfect illustration of this principle in action. This isn't just a planning document. It's a tool for ethical design. Look at how this clarity immediately drives the technical choices. Because the user was defined as pregnant women in Kisumu, the team knew voice interaction was essential to bypass potential literacy barriers. Because the outcome was detecting a life-threatening condition within 48 hours, they built a hard-coded, non-negotiable rule. The AI must escalate to a human doctor if its confidence ever drops below 85%. And because the specific harm they were preventing was a misdiagnosis leading to death, they made the decision to store that sensitive medical data locally on the device itself, not in a more vulnerable cloud server. This is the key takeaway. Vague problems lead to technological guesswork. Precise problems lead to elegant, effective, and ethical solutions.
So, if a clearly defined problem is the why of ethical AI, this next foundational step is the what. Step 2, audit your data. Data is the raw material. It's the clay from which your AI will be sculpted. Everything it learns, every pattern it recognizes, every single decision it makes originates from this data. Which brings us to what Marcel calls one of the most dangerous and persistent myths in all of technology: the idea that data can ever be truly neutral.
Data isn't neutral, it's relational, and often biased. I really want you to let that sink in for a moment. We love to think of data as pure, objective truth. It's not. Data is a reflection of the world it was collected from, with all of its existing complexities and biases. Every data set is like a fossil record of the past. It's a snapshot of our historical decisions, our societal priorities, and yes, our prejudices. And when you train an AI on data that reflects a biased world, that AI doesn't just mirror the bias, it amplifies it. It codifies our messy human prejudices into what looks like objective logic, and then it scales that bias at a speed and scope that humanity has never seen before. A Know Your Customer agent in Dar es Salaam, designed for financial services, started flagging women in hijabs as high risk. Now, was the code programmed to be discriminatory? No. It had simply learned from the Western-centric data it was fed, data that had virtually no images of African Muslim women. The system wasn't just inaccurate, it was actively discriminatory. So, what's the fix? Marcel proposes this rigorous 3-level data audit, and it's non-negotiable. First is representation. This is the most basic check. You have to look at your data and ask the hard, honest question. Are all of our intended user groups actually present in this data set, or is somebody missing? Second, you have to dig deeper and check for bias. Does the data accurately reflect the real-world diversity of the population it's meant to serve, across culture, gender, geography, age, and more? Or does it overrepresent one group at the expense of another? And third, provenance. This is absolutely crucial. Where did this data come from? Was it scraped from the web without permission? Was it purchased from a shady data broker? Most importantly, was it collected with the full, informed consent of the people it describes? Is it ethically sourced? This isn't just a technical process, it's a deeply ethical one. This brings us to the third and final piece of our foundation, and it's essential for building trust. Step 3. Choose explainable models. The guiding principle here is simple, but it is profound. If you cannot explain how your AI reached a decision, you should not deploy it, especially not in a high-stakes environment like healthcare or finance or law, where its conclusions can have life-altering consequences for real people. The era of accepting "the computer says so" as a valid answer is over. This slide shows a fantastic, practical example of this from Malawi. On the left, you have a black box model. It takes in symptoms and it spits out a conclusion. I think it's TB. The patient and even their doctor is left with a declaration without any reasoning. There's no why. On the right, you see the alternative. The team in Malawi uses an explainable architecture for their tuberculosis screener. It's called a RAG LLM, Retrieval Augmented Generation. Now, that sounds complex, but the idea is simple and brilliant. Before the AI gives any advice, it is forced to first retrieve information from a trusted, verified source. In this case, the official World Health Organization guidelines. This means its output isn't a guess from a black box, it's a reasoned statement that can be traced back to its source, building confidence and trust. Marcel's advice here is to prioritize these kinds of explainable models. Even if you have to use a complex model, there are tools you can add on top of it that act like a why button for the AI's decision, because an AI that can't explain itself can't truly be trusted. Okay, so our foundation is solid. We have a clearly defined problem, we've meticulously audited our data, and we're committed to explainable models. With that bedrock in place, we can now build the next layer on top of it, the human safeguards. These next two steps are all about protecting the people who use your system and weaving human wisdom directly into its daily operation. This brings us to step 4, implementing privacy safeguards. And on this point, Marcel's perspective is uncompromising. Privacy isn't an optional feature. It is not a nice-to-have that you can add later if you have time. It is the absolute non-negotiable cost of entry for any system that handles human data. Without it, you have no foundation for trust. And without trust, your AI is ultimately useless no matter how technologically clever or accurate it might be. The stakes could not possibly be higher. The story of a mental health app in Lagos is a chilling reminder of what happens when privacy is treated as an afterthought. It was an app built with the best of intentions, but it stored raw, unencrypted voice logs of therapy sessions. It was hacked. 10,000 private, deeply personal, and vulnerable conversations were leaked onto the open internet. The damage is incalculable. So what's the solution? Marcel advocates for a principle called privacy by design. This means privacy isn't something you tack on at the end. It's built into the system from the very first sketch on a whiteboard. This involves a strict regimen of controls. End-to-end encryption is the baseline. Anonymization is critical, stripping out any personally identifiable information before data is analyzed. And a principle of minimal storage. The rule is simple. If you don't absolutely need the data, don't keep it. Auto-deleting sensitive data after 30 days should be standard practice. If you must keep sensitive data, you have to protect it as if a life depends on it. Because as this case proves, it just might. The next human safeguard is step 5. Involve domain experts early and often. This principle pushes back against a common and dangerous form of hubris in the technology world. The idea that a small team of brilliant engineers, armed with enough data and computing power, can parachute into any field and solve its problems without outside help. Marcel's argument is simple and powerful. An AI built in isolation will always fail when it meets the complexity of a real community. You cannot build effective healthcare AI without doctors and nurses. You cannot build functional financial AI without accountants and regulators. And you absolutely cannot build useful agricultural AI without talking to farmers. In Tanzania, a team building a healthcare AI fundamentally changed their entire process. They hired local nurses not just as occasional consultants, but as full-time AI co-stewards. As this slide shows, this is a deep, ongoing partnership. So what does it look like in practice? Well, the nurses label medical data, using local languages and cultural contexts that a data scientist thousands of miles away would never understand. They are empowered to correct the model's outputs on a weekly basis, creating a constant real-world feedback loop that makes the system smarter and safer over time. And most importantly, they must approve all high-stakes recommendations before they ever get sent to a patient, acting as a final human check and safety net. This is the fix, embedding experts into every single phase of the project. They are the ones who catch the subtle but critical blind spots that engineers, by definition, cannot see. So, we've built our foundation of problem, data, and explainability. We've added the human safeguards of privacy and expert involvement. Now we come to the final, crucial layer of the structure, the systemic checks. These last two steps are about ensuring the AI operates equitably once it's out in the world, and that a robust system of oversight is in place to catch and correct the inevitable errors. This is how you build a resilient, self-correcting system. Step 6 is to test for fairness, and it is so critical to understand that fairness isn't a single metric you can just optimize for. It's not a number that turns green on a dashboard. It is a multidimensional, ongoing commitment. An AI system can be 99% accurate on average and still be catastrophically unfair to a specific subgroup of its users. In Kenya, a loan agent was performing well on paper, but a formal fairness audit revealed the truth. By slicing the data and testing for performance across gender, age, and geography, the team discovered the model trained on traditional financial data showed significant bias against rural women. So they rebuilt it. Unfair AI doesn't just produce bad outcomes, it erodes trust and it can actively amplify existing societal inequalities. The fix, according to Marcel, is to run dedicated fairness audits using established open-source tools that can help you find these statistical disparities. But that's not enough. The most important test is real-world testing with the diverse user groups your AI is meant to serve. And this brings us to the final and perhaps the most important step in the entire protocol. Step 7,
Set up accountability channels. Accountability isn't a feature you add at the end. It is the essential safety net for the entire system. It is the definitive answer to the most important question of all: what happens when things go wrong? Because they will go wrong. No system is perfect. The true measure of an ethical AI is not whether it is flawless, but whether it has a robust, transparent, and effective mechanism for identifying, flagging, and correcting its flaws. This slide provides a clear and practical model for how to build accountability in layers. It's not a single action, but a continuous process woven through the AI's entire lifecycle. First, at the pre-launch phase, every high-stakes project must pass through an ethics review board. And crucially, this board should be composed not just of engineers, but of doctors, ethicists, and community members who can provide diverse perspectives. Second, post-launch, the domain experts we talked about earlier must conduct weekly audits, reviewing the model's decisions and performance to catch any drift or emerging biases before they become major problems. And third, and most critically, there must be a user-facing channel. The example of the simple Report This Output button in Uganda is a powerful mechanism. It gives users agency and creates a direct channel for flagging errors, which triggers an immediate human review. An AI that can't be held accountable is not an asset. It's a liability waiting to happen. So those are the 7 steps. Define the problem, audit the data, choose explainable models, safeguard privacy, involve experts, test for fairness, and set up accountability. Marcel argues that while these principles are universal, the philosophy behind them is what provides a deeper, more sustainable advantage. While many organizations still treat ethics as just a compliance issue, a final check before shipping, the approach he's talking about is about weaving these principles into the very fabric of the design process, with a focus on humility, community, and genuine care for the end user.
Marcel's perspective is that in tech hubs like Nairobi, Kigali, and Lagos, builders often don't have the luxury of infinite computing power or endless venture capital. They can't afford to get it wrong and shatter community trust. And that constraint, he believes, forces them to think deeper and clearer and wiser. He argues this constraint is becoming a global advantage. And so his challenge to every builder, founder, and engineer is this: don't just work to avoid ethical traps in a defensive posture. Instead, go on the offense. Proactively build an ethical immune system for your products and your organization, an immune system that is grounded in the real needs and human dignity of the people you are trying to serve.
Because in the end, the future of AI won't be governed by who writes the best policy papers or who has the biggest, most powerful model. It will be governed by who lives the deepest values, day in and day out, in the code they write, the teams they build, and the systems they deploy into our world. If you've found this explainer valuable, please consider liking it and subscribing for more deep dives into complex topics. Next, we recommend checking out our explainer on the evolving role of the modern AI engineer. Thank you for joining us.